Now we're going to look at the next process of factoring, which is a process of grouping. Grouping is normally done when we have a polynomial with 4 or more terms, especially when we know or can identify that there is no GCF. So the idea with factor by grouping is that we want to group the terms so that parts of our equation have a GCF and other parts also have a GCF. And ultimately, we're trying to create something that looks like what we saw earlier with those last two examples, where we have a common binomial as our GCF. And so generally what we do with factor by grouping is we split it in half. And we look to see within each pair of terms if there's a common factor. And when we take the common factor out of each pair of terms, we want to make sure that we have a binomial GCF within each grouping that is in common. So we look at our first two terms, AB minus 6A. Well, we can identify that we have the common factor of A. If I divide A out of both of these terms, I'm left with B minus 6. In the second grouping, we have a common factor of 2. If we factor out a positive 2, we're left with B minus 6. Divide both of those terms by 2. And we identify that, well, we do have a common binomial factor of B minus 6. So within the term A, B minus 6, and the term 2, B minus 6, within each term, we can factor out the GCF of B minus 6, which leaves me with just A plus 2. And now we have our factored binomials. Looking at B, we can split it in half. And we want to identify the GCF of the first two terms. Here we have the lowest degree of x's being x squared, leaving us with x plus 5. And here we have a numerical GCF of 3. So we factor out plus 3, leaving us with x plus 5. Since our binomials match, we can factor them out as the GCF of our two new terms, leaving us with x squared plus 3. For C, we split it in half. We have two terms on the left and two terms on the right. The GCF of the first two terms is m squared, leaving us with n squared plus 1. And on the right, we have a GCF of 2. We could factor out 2, but I want you to notice that our binomials don't match. If we factor out a 2, we don't get a matching n squared plus 1. So let's back it up a second. We know that our binomial needs to be n squared plus 1. So we have to look and analyze and see, well, what can we factor out that changes the signs from negative to positive? We factor out a negative 2 instead. That creates these binomials to match, n squared plus 1, and then we're left with m squared minus 2. Last but not least, we split the 2. We've got a GCF of x, leaving us with y plus 2. And then we need to again look and see, what can I factor out that leaves me with a y plus 2? Well, I have a negative y minus 2. 1 and negative 1 are always factors of any polynomial. If we factor out negative 1, that changes the signs. Then we have our matching binomial and the resulting binomial that's left. If we can't find a factor pair that works and we can't get a matching binomial pair, then we have to try a different grouping. And so we can often rearrange our polynomial in a different manner that allows us to factor it. Let's take example B. I don't have to split it as I did here. I could rearrange the polynomial by switching the 3x and the 5x squared. And I can split my grouping this way. I have a GCF of x, leaving me with x squared plus 3, and then a GCF of 5, leaving me with x squared plus 3. Now my matching binomial pair is x squared plus 3, and when it's factored out, I'm left with x plus 5, and we see that we get the same result.